Hey everyone, I'm going to be going over the Introduction to Computing and Programming in Python, Chapter 2, Introduction to Programming. So the chapter learning objectives are the media learning goals for this chapter is to make and show pictures and to make and play sounds. The computer science goals for this chapter are to use JES to enter and execute programs, to create and use variables to store values and objects, such as pictures and sounds, to create functions, to recognize different types encodings of data such as integers, floating point numbers, and media objects, and to sequence operations in a function. So here's an here's the installation for JES. I'm gonna be posting something instead of what this says, so we'll just skip this for now. So much of programming is about naming. We have to name our data. So data is the numbers that we manipulate, and we call our names for data variables, right? So we've all done some math. Let me switch real quick. We've all done math where perhaps we have y equals x plus 2, for example, right? And we know that y and x are called our variables. Well, when we create a function, when we're programming, it's done the same way. And we also name our recipes. And the quality of names determine much as in philosophy or math. So your variable name should be enough words to describe what you need to describe, and they need to be understandable as well. So let me go back to here, for example. And what if I were to say, um, let's just say age equals 15, name equals Steven. Then we're going to say print my name is space plus name plus and my age is plus age. So if we look at this, I created a variable and I set the value of the variable to the number 15. And then I created an additional variable called name and I set that value to the name Steven, right, which is actually a string. And then I want to print my name is, print my name, then and my age is, and then print my age. So what I'm going to do as we go through these chapters is I'm going to actually do these with you. So if I make mistakes, we can look at the errors and learn from them. And then you guys can hopefully follow along with these as well. So I'm going to hit load. And when I hit load, it wants me to save the file. And I'm just going to call it test for now because this is just an example of what we're learning. So I'm going to hit yes. So when I hit load, it's saying cannot concatenate string and int objects. So what this error means is that this is an integer, right, which is a number, and uh, it can't put together my numbers and my um, it can't put together a string, which is like a sentence, and my integers. So let's try to see if this should fix that. Okay, so what I did is I cast the number here as a string. So str makes it a string. So this is like me saying I want the number 14 to actually equal 14 like a string like that. So hopefully that makes sense. So let me actually go here and clear my command window again and let me load it. So it says my name is Steven and my age is 15. Right? So these variables, they make sense for what I need. They don't need to be more complicated, right? They don't need to say like the age of the person typing, right? That's super complicated. And then it's not going to be like age like this, right? It needs to be age and it needs to make sense, something simple like that. Same thing goes for name. So let's go back to here. So we naming our encodings is important too. So sometimes we refer to these encodings as types. So numbers without decimals are called integers, right? And that's what we kind of just went over right here. So this 15 uh, is actually an integer, right? Numbers with decimal points are called floating points or floats. So if I did this, that's a floating point, right? Because there's a decimal. Similarly, a collection of letters is called a string. So this right here is a string. This right here is a string. When I cast this, which means I'm taking an integer and making it something else, that's me casting an integer to a string. hence the abbreviation for this method called str. So some programming languages are strongly typed. A name has to be declared to have a type before any data is associated with it. For example, if I were to use Java, I would actually have to say um, uh, int int equals 4, for example. So in this example, I'm saying, oops, let me say integer. I'm saying I have an integer. This is the type. This is the value, or this is the variable name, and then I'm equaling it to 4. But we're not doing that in Java, and Python doesn't actually require that. So some examples of types, like I just kind of went over, there's integers, right? They can be positive or negative. There's floats, which can be as many decimals or as little decimals as you want. And then there's also strings, which is words like Mark, Barbara Erickson, and then and street names as well. But inside the computer, these are all just bits. So our programs work with a variety of names, and you're going to name your functions. Just like functions you knew in math, like sine and greatest common divisor, you will also name your data, which is the variables. And you're going to name the data that your functions work on, and these are called inputs, like 90 in sine of 90. So let's do a quick example. So I'm going to delete this. All right, now I'm going to define something that says print welcome greeting. And I'm going to take something called name. And then I'm going to print welcome to chapter 2 examples plus name. Awesome. So now I'm going to actually call my function. Let's just, I'm going to type this real quick and then we can explain it. So I define a function. So def is the abbreviation for define, and I call my function print welcome. Oops, it should be greeting because right that function name makes sense. We can understand it readably what this is going to do, and then I pass it an input called name. And name is just going to be my name. So this is the function definition. So if I don't include this line here, let me just cut that real quick, and I load this and I save it, it does nothing, right? But actually what I can do is call it down here, print welcome greeting, and I can say Stephen. Welcome to chapter 2 examples, Stephen. So if your name was Shenzi, like my dog's name is, you could say welcome to, right? But it's not smart enough to know that it's a name or not, or I could just do some random numbers as a string, and it does the same thing. But what if I wanted to print it as soon as I hit load, which we'll probably be doing in class or future assignments? I'll say print welcome greeting, and I can say Stephen here, and then when I load this program, it prints it automatically, right? It runs and executes right away. So hopefully that makes sense. So here is my function name. This is my input. But then my input that I get is I'm actually going to use that same variable here as well. Okay, so let's go back. So the names inside a function only have meaning while the function is being executed by the computer. So names for things that are not in memory. So a common name that you'll deal with is a file name. The program that deals with those is called the operating system. You have Windows, Mac operating system, Linux, even on your iPhone, iOS is an operating system. A file is a collection of bytes with a name that resides on some external medium, like a hard disk. Think of it as a whole bunch of space where you can put your bytes. Files are typed, typically with three-letter extensions. You have JPEG for pictures and WAV files for sounds. So we're going to be programming in JES like you've seen me using. It's a simple editor for entering in our programs or recipes. We'll call that the program area. The command area is for entering in commands for Python to execute. So here's an example of what this looks like, and you can see based on what I had, it's the same thing. So the top area where we're actually programming is called the program area, and the bottom part is the command area. So JES with help displayed, this is showing you where the help actually is. So let me switch real quick. we can actually go to JES functions, for example, and say I want to learn how to use the pick a file function. When I click on that, you can see that this help comes up on the side, and it tells me not only an example of how to use this function, but it tells me the return value of the function. And we'll learn more about return values soon. So a tour of JES, we're going to skip this because this is pretty straightforward. But you can go ahead and try it yourself to do some save and save as well as cut, copy, and paste with shortcut keys and the help thing. So Python understands commands. We can name data with the equal sign, and we can print values, expressions, anything we want with print, like I've shown you in my example. So what we'll do, let me clear this and let me close this. Right, so what if I were to say uh, uh, test equals 1? We can do some things down here in the command window. So right now I took the variable test and I assigned the value to the variable of 1. So now if I type test, it'll print out what the value is. Cool. So, but what if we use two equal signs? Now, when we use two equal signs and it no longer assigns something, we can say this is actually checking for equality, right? So if I say test equals 4, we should see the return value of false because this is saying does the variable test equal the value of 4, right? And it doesn't. But what if we have test equals 1? In this case, this is equal, so we should see true, which we do. But now let me say, what if we say test equals 4? So I updated the value of 4. Now does it still equal 1? No, right? Because we updated the value of test. So back to the PowerPoint. So names can be nearly whatever we want. Some things to note that they must start with a letter, and be careful not to use commands as your own names. So if we were to say print equals 1, it's not going to work, right? Because print is already a function. So we can't make a variable called print when print already does something. And another example, case matters too. So if I were to use print equals 1, that actually works fine. So I could say print, and it actually prints the value. But using names like that is not good practice, and as well as starting with a capital letter is not actually good practice either. So you'll see in my example here, this is called camel casing, right? I'm always going to start the first word lowercase, then the next word, capital first letter, lowercase rest, capital first letter, lowercase rest. So if I were to make another function, let's say we're going to say print goodbye message. See my camel casing as well here. Same variable name. I'm going to actually copy and paste this to speed this along a little bit. I'm going to say goodbye from chapter 2 examples, and then we're going to print the name there as well. So now I'm going to copy this. I'm going to say print goodbye message, and we're going to hit load. I hit yes. So now it says welcome and it says goodbye. Again, using best practices, I make my name variable, my input, I make it understandable what it is. I make my functions names that are not only in the right case sensitivity, but they also are names that make sense as well. So using JES, we can do things like adding integers, dividing floats, multiplying integers, subtracting integers, printing strings, and it may be concatenating or adding two strings together. So we can do this as well. So let me clear this command window. So what if I want to say, hey, what's 11 plus 3? Cool, it's 14. What if I want to say, let's see if we can do pi. See, we can even see what the value of pi is. What if I said pi times 50? Cool. What if I want to say pi times 50 divided by 3.14? 50 and some change, right? Because pi is a pretty big number. So what if we continue with 67 times? Oops. So this you can see I got invalid syntax, but you'll see that I have this slash at the end because I was typing too quickly. We type that, and it's the same thing. Cool. Continuing. So values and names with the same value are interchangeable. For example, we can say print 12 times 3, or we can set the value equals to 12 and print the value, or we can say print the value times 3, right? So we can not only um, print the name. Here, let's actually just do some tests. So let's clear this again. So we'll say name equals Stephen. Then we can say name times 4. Stephen, 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 Stephen. This is some of their examples. So I hope you guys can follow along with some of these examples too. But let's see what happens. I'm actually not sure what's going to happen with this. What if we do name times pi? So here we get an error message that says the error value, you can't multiply sequence by a non-integer of type float. Right, so it knows that the pi is a float, which we learned about before, right? Because it has a decimal. So we can't multiply something to repeat a certain number of times by something that is not even a whole number. So if we say pi times or name times 4, it makes sense. Say name times 3, it also makes sense. But again, we can't use a float. We have to use an integer. So equal is assignment, not equality, like I said. So when you see the equal sign in Python, you read it as figure out the value on the right and then give it the name on the left. For example, you'll see size equals 12.5. So figure out the value on the right. So it says that's 12.5. And then we're going to give it to the name on the left. That's size. So then we have size equals 12.5. Similar, we say total equals size times 34. So we take size, we multiply it by 34, and then we set that to the variable total. So then total equals, in this case, 425. So math may be surprising sometimes. If you only use integers, numbers without decimal points, Python thinks you only want integers. For example, let's do 1 divided by 2. It's actually 0. But we know that's not right, correct? So it's actually rounding for us. So if we do 1 divided by 2 like this, 0.5. So one of the values has to be a float, and then you'll get the right answer. Because in right, we said before that computers aren't smart, right? Python's, again, not smart either. We have to tell it what we want so we can get the right output that we expect. So which one comes closest to but doesn't reach 1? We have 4 divided by 6, 4 divided by 6.0, 4 mod 3, or 4 mod 3.5. So let's see if I can do clear. Nope, none of this works, sorry. So we're going to clear the command window. We're going to do 4 divided by 6, 4 divided by 6.0. We had, going back, 4 mod 3. So we have 4 mod 3, which is 1. And we have 4 mod 3.5, half. So what mod is, or modulus, it actually is the remainder when you divide these. So you divide it, it has 1 left over, divide this, and it has 0.5 left over. So based on which one comes closest to but doesn't reach 1, we say the answer is 4 divided by 6.0. So command area editing. Up and down arrows walk through the command history. I actually probably used this, but I didn't actually explain what I was doing. So I'm hitting the up and down arrows, and it actually goes through everything that I typed previously. So if you want to type something that you already had and it's complicated, for example, name equals Steven, and then I could say keep going back up, name times 4, and then it prints the same thing. And then you can edit the line at the bottom. Just put the cursor at the end of the line before hitting return or enter. So for example, if I have this, I could just come in here clicking. I could say this, right? We should get an error because this weird name doesn't exist, right? So it says the error value is not defined. So what I'm doing, trying to get, as we work through this, is I'm trying to show you guys common errors too, so you can kind of understand how to troubleshoot these as well. Because some of these errors you will definitely face as you go through the course. So JES functions. A bunch of functions are predefined in JES for sound and picture manipulation, such as pick a file, make picture, make sound, show, play. Some of these functions accept input values. So what do we do to show a picture? We find a file with a picture, pick it. We get the bytes from that file into memory, and we label it as a type picture, and then we show a picture. So pick a file leads to the file picker. So I'm going to go through this, and then we'll do an example. So make picture takes a file name and creates and returns a picture object from the JPEG file at the file path. Show a picture displays a picture in a window. And we'll learn some functions from manipulating pictures later, like get color, set color, and repaint. So as we're on picture functions, let's go back and let's define a function called get picture. It's not going to take any input or any input. We're going to say we're going to say picture equals pick a file like this. Then we're going to say picture equals make picture with picture. And then, well, let me actually change this. Let's change this to file and file here. And then we're going to say show picture. So now I'm going to load this. We're going to see it not do anything, right? Let me clear this window again. Load it. Okay. So now if I call get picture down here, we see my file prompt. So let me go to desktop. There's going to be a lot of stuff on here, so I apologize. Week 1 assignment. And let's show lope picture. So we see an antelope picture. So what actually happened when we ran this? So the first thing that happened is file equals pick a file. So this runs, but what you might be asking, what does this actually do? Well, now we have this button down here that says explain pick a file. So we click on it, and it says it returns the string path to the file chosen in the dialog box. So to get some more clarity, let's actually print out file here, because we want to see what it's actually printing. So, or what it's actually getting. So we're going to hit load again. I'm going to hit get picture. I'm going to point here. But you'll see now in my command window that we actually printed out, oh, here's actually the file name, which is lopepicture.jpg. So that's what's right here. So then once we print the picture, let's do this again. This actually should print the bytes, so it actually might be a pretty intensive command to print out in our command window, but we'll see. So let's load program again. We're going to call it again. We're going to pick the picture. Oops, sorry. So it actually didn't. It printed out that we have a picture. The file path is there. The height's 390 and the width is 870. Cool. So back to explaining this again. So we set our variable, right, with a name that makes sense because it's a file. We pass our file into the make picture function. Make picture takes a path. It's the name of the file you want. And then it returns a picture object made from the file. For example, their example, they do something actually pretty similar. And at the end, we want to show something, right? So show shows the picture provided as input. So here's an example of called open show, and it's pretty similar to the example that we have ourselves. This can be optimized, so I'll show you quickly how to optimize it. I'm not expecting you guys to do this right off the bat, but eventually, if it makes sense for you guys to do it in one line, you guys can do it in one line as well. So we could actually say make picture, and we could say pick a file. So we could actually do this without assigning any variables at all. So what it's going to do, it's going to call show. Show is going to call make picture. Make picture is going to call pick a file. Pick a file returns, populates make picture, and that populates show. So let's just test this wild one-line code. Something's wrong with the text you had me load. Oops, I think I'm missing. So parentheses matter as well. I think I'm missing a parenthesis. Awesome. So it loaded. Cool. And it did the exact same thing, but we just didn't create a variable for it because we really don't need to, right? You can do it just as easy as this. So when you guys start out, I would definitely recommend starting like this, right, where everything's commented out, or not commented out, but everything's the variables are labeled in a way which you guys understand, and then eventually, as you get more advanced, you guys can do it in one line if you wanted to. So like the book said, there's definitely multiple ways to do this, and recipes are all different, right? So let's go back to here. So we learned make picture. Now there's sound functions. We're gonna skip that. I'm gonna skip that through this example, but you can use some functions as well. So I encourage you to look up the make sound function, the play function, the blocking play. Look them up in JES. Understand how they work. Play with them a little bit. Follow some examples through the help, and then see if you guys can get those to work. So here's an example where we just did this. So we're going to skip over that, skip over this as well. So in their example, they show a picture as well. You can also grab things from the internet. We're going to skip through this. Actually, here we'll go here. So blocking is indicated for you in JES. Statements that are indented the same are in the same block. So that might not make a ton of sense right now, but we should be able to see. I'm not sure why I'm seeing it. So this is indented over in one block. So it's not really for some reason it's not showing me currently. But you can see in here this is all within this pick and show function. Right, so the statements that are written in the same block as where the line where the cursor is enclosed in a blue box. Right, so you can see everything. Let me try this again for a second. I don't know why it's not. For some reason, it's not actually showing me on my screen, but I've definitely seen it before. So, but like this example shows you that that entire function shows what the pick and show function entails. So the most common JES bug is forgetting to hit load. So your function does not exist for JES until you actually load it. So before you load it, the program is just a bunch of characters, right? It's a bunch of characters in the programming area, and loading encodes it as an executable function. So save and save as you must save it before loading, and you must load before you can use your function. So an unloaded function, it doesn't exist, right? It's not anything. So I go back here. Um, and I try, say I type define print what's up, dude, right? And we're just gonna say print hello friend, right? Just something fun. So if I try to go down here now and I say print what's up, dude, it's all confused, right? The error value, what's up, dude, is not defined, name not found globally. But now if I load it, and I try it again, hello friend, works totally fine, right? So I didn't load it, so make sure you guys watch for that. Make sure you, again, go through some of these examples. So making functions the easy way. Get something working by typing the commands. Enter the uh, def command, define, right? Copy and paste the right commands up into the recipe. So in this example, we're gonna you can either type this, you can type this yourself, or copy it from the book. But we're defining. We actually did something just as similar to this, but we did for picture. This is for sound. So we define a function called pick and play. Again, notice the camel casing. We set a variable called myFile, and we equal that to pick a file. Then we create a variable called mySound, and we equal that to the function makeSound, and we pass it myFile, and then we play it. So myFile and mySound inside pick and play are completely different from the same names in the command area. So, for example, myFile and mySound are only inside pick and play. Um, for example, I'm trying to think of something. So, say that you have um, a notebook, for example, and you write your name on page one, and you turn this piece of paper in, and then um, you lose your book, for example, right? Your name was only on that one piece of paper. So now that you ripped it off and turned it in, your notebook is no longer it no longer knows its name, right? So similarly, just like that one page has the scope of your name, right? Your name is only on that page. There's a small scope of one piece of paper that includes your name. This is the same kind of thing. So my file is only in the scope, which you'll learn about this word, the scoping later, but my file is only in the scope of the function called pick and play. Outside of pick and play, my file means nothing. It only means something inside the block, right, which we saw before with the blue box. It only means something inside the block of pick and play. So go ahead and try this example out. Get a sound file that you can test and see if this works for you in JES. So here's another example of something we already tried earlier too. Again, I'm gonna pause here for a quick second. Definitely check this out, right? Hopefully, I want you guys should be able to explain what this does line by line. Again, I'll explain it, and then hopefully it makes it easy for you. So we define a function called pick and show, and inside those parentheses we have nothing in there, right? That's because it doesn't take any input, right? We have a colon because we're defining this function called pick and show. Then inside this block for the function, we say my file equals pick a file. Then we have my pick equals make picture with my file passed into it. So make picture is taking a file path that pick a file returns. And then show picture takes the my picture variable and actually presents it to the screen. So what if you forgot your variable names? You can actually do something called show vars, which we'll try right here. Show vars. Cool. So this is showing me the variables that I had recently. Let's open this real quick. So you'll see we have local variables. These are variables that were created inside the command, or not inside the program area, and these were command area variables. So you'll see it's the value, the type, and the name of the variable. These are functions, and it's actually showing you the memory location where these functions are stored at, right? Because again, functions just encoded to somewhere and then in memory, and then we execute it when we call it. So I'm going to close this. So a function for a specific sound or picture. So we can say play sound. We can say my file equals. We can actually hard code a file name. And hard coding means, as this example shows on the bottom, it would be C, like on your C drive, maybe your documents or your downloads, and then you can point it directly to um, your specific location. So, for example, I can bring up desktop week one. I could actually copy this. So let's go to properties. Sorry if you guys know a shorter way to copy this file path, go ahead, but this is the quickest way that I know. So I can actually go down here and I can actually give it a string right here, right? And this points directly to the lopesound.wave file, which would be the exact same thing that my file picker or my pick a file would return, but I could actually hard code it should I need to as well. So like it says here, you can always replace data, a string of characters, a number, whatever, with a name variable that holds the data, or vice versa. So you can see in these examples, which you guys I hope would test as well, you can point to the C drive, you can point where your pick a file points, so you can point to that directly as well. So what to do about window file names? So Python doesn't like to use backslash in file names like C backslash media sources backslash barbara.jpg. So what do? Option one is to put an R in front of the Windows file names, like R and then or quotation marks and then the file path. Or you can use forward slashes instead, and Python's actually smart enough to translate it for you. So a function that takes an input. So in these examples, we can say play named, and it takes an input my file, and show named takes an input my file. So what functions do you need and what should be their input? In general, have enough to do what you want easily, understandably, and in the fewest commands. And we'll talk about more what that means later. But as to give you an example, like we did previously, I can give it name and say I give it age, for example, too. Okay? And we're going to say hello friend plus name. Oops. So now if we say print what's up, dude, and we say Steven, now let's try this actually. We should get an error. So let me clear out my command window again. And we're gonna say load program. Oh, we got an error. Now this is saying the error value is what's up, dude. takes two arguments, but only one was given, right? We're expecting name and age, but I'm only saying name. So let's say 15 again. And again, my age is not actually 15, so this is just an example. So we're going to hit load, I'm going to hit yes, and it says hello friend Steven. So this works as we intended, but based on what we read, right, it says easily understandable and then the fewest commands. Um, does this make sense to have the age as part of an input when we're not actually even going to use it? Not really, right? So we're going to get rid of that. We're going to get rid of this. So now we hit it. It uses every variable that we, or uses every input that we give it, and it makes sense. But what if we wanted to make this a little bit different? So what if we define a function called getName, takes no parameters, and all it does is returns the input, let's say raw input, please enter your name. Again, I encourage you to try these examples as we go through them as well. Print name. So right now I created two functions. I created one that says get name, and all it does is returns the raw input of please enter your name. So what we're gonna do now is we're gonna load this, and we're gonna say get name. So when I hit that, right, it says please enter your name, and it starts spinning, and you can see it's the next to this on this far right side, you can see this blue thing going back and forth. It's waiting for an input. So now I'm gonna say my name is Steven, and all it does is return that, right? It prints my name Steven back out. So now what if I say print name and I say Steven? That's again going to print Steven. But how do I use these together? Well, what if I said print name and then I said get name? Enter the name you want, Steven, and then it prints Steven. So how this works is that my get name, this is what it means by easily understandable functions as well. So my get name literally just gets my name and returns it back as a variable. And then print name here takes an input. So this returns an input, this takes an input, and then it just prints the input that I give it. So altogether, we can put these together again like I showed down in the bottom. We can say get name like this. So I hit load. As soon as I load it, it's going to ask me for a name. I'm going to use my dog's name again, Shenzi. I hit enter, and Shenzi prints out. So hopefully that makes sense. So where could you go wrong? So did you use the exact same names? So for example, if I were to say, um, if I said print name and I said print name like this, I'm going to hit load. It might not even compile. Oh, so it actually did compile. But if I say Steven, now it's going to throw an error because the error value, global name, is not defined. So there's nothing called name. It's confused because this is a capital, but this is a lowercase, right? So we have to be super careful when we do that. All the lines in the block must be indented and indented the same amount. For example, if I have something here, print hello, uh, hello, dude. But say I indented this like way over here. This is not going to work, right? Because it says indented the same amount, right? This is not the same amount as this is not the same amount as this one. Variables in the command area don't exist in your functions, and variables in your functions don't exist in the command area, right? They're two individual things. So if I create something if I tried to print this name down here by just typing name, let's just try it. Actually, so this actually did work because I defined name previously, but generally this actually wouldn't work. So that was a bad example. Actually, this is actually holding all my, oops, my bad. Hold on. We got in some weird state right now. Let me actually here, clear command window. Okay, I'm not sure why that was like that. So we're gonna say show vars, and now we can see all the variables that we've created, right? So that we can actually see that name is there, which is why it's printing. It just happens to be in both the command window as well as the program area. So we'll go back to our here. As well, the computer can't read your mind, so it'll only do exactly what you tell it to do. So the most important thing to do to pass this class, do the examples. Try them out for yourself and try to replicate them. Understand them. Every week, type in at least 2 of the examples from the class. To understand a program means that you know why each line is there. You will encounter all of the simple but confusing errors early, before you are rushing to get your homework done. So, like I said, go through these examples that I went through and I typed in with you guys, and try to understand what each line means. You can as well comment things out. So let me go back to here. So if I'm going to do this, say I can add a comment. So if I'm gonna forget what it's gonna mean in the future, I can say this line gets the name of the user from the command line. And I can say here, this line prints out the user's name in the command line. I can say command area as well, doesn't matter. Right, so the more you guys understand, and you can comment as much as you want. You can comment here if you wanted to. Defines a function called getName. And I would definitely encourage you guys to actually use something like this too, at least starting with, so you guys understand what each line's doing. And hopefully it'll help you get organized as you start to learn programming and you start to learn different programming methods, functions, and you start to get dive deep into the programming world. Again, like this says too, please try to start your homework early. Um, you have a week plus generally to do it, so the earlier you start, the quicker you get out of these little errors, like we saw as I was going through some examples. We get rid of these little errors, and we can focus on the content and what is important with what you need to work on. So that's all we have for chapter 2 for this textbook. I definitely recommend going through the reading still. Do the examples that the book has. Hopefully they make sense. If you guys have any issues, feel free to email me. Hopefully this tutorial made sense. Again, if you have any questions, feel free to reach out. Thanks, guys.